So this circuit is the basic circuit. This is the hello world. What can do is it'll put out a pulse and we'll hook up a little LED and watch it blink. But like I said before, there are thousands of different circuits you can build, different applications for them. So the first thing I'm going to do is I'm going to set up this rail on the breadboard. How this works, these lines up here are all connected. So I'm going to hook my positive power to that, and my negative power rail is down here. So when I want to get ground, this is a symbol for ground, I'm going to attach ground to pin 1, and then positive to 8 and 4. So positive to 4, positive to 8. And of course you don't want to be doing this with the power actually on these, because you might misconnect something and burn up your chip. So we have 1 to ground, 8 and 4 to positive. Alright, now we need some other components. This is a capacitor, a resistor, and a potentiometer. And basically the different combinations of these components can give you different frequencies. So if you have a 0.22 capacitor and R1 right here is 10K, then you're going to have 540 pulses per second. So you can see in this circuit they're expecting you to be producing a frequency that is so high you couldn't detect it with a visible eye. But so basically, if you get a bigger capacitor and more resistance, you can get it to blink 6 times per second right here. So I'm going to actually use a 10 microfarad capacitor, and this little curved line on the capacitor indicates that the line, or the negative side of the capacitor, is facing towards ground. So that's between 2 and 1. And then there's a jumper between 2 and 6. And then a 1K between 6 and 7. I am going to use a 10K because I like the way it blinks better. Then from 7 to positive, we have a potentiometer. I don't have a 1 meg, so I'm using a 100K. Alright, and then this output is open, but we would like ours to do something, so I'm going to use an LED. The shorter pin is ground, so I'm going to set it right here. And then I'm going to use a resistor to go between pin 3 and the LED, because an LED will pull quite a bit of current if you just connect it directly up. You'll heat up your chip and you'll heat up the LED, so you definitely want to limit the amount of current you let your LED pull. Then we apply some power, 9 volts in this case, and our circuit works. If we turn our potentiometer, you can see that it blinks differently. Voila! Alright, now I want to do a basic monostable circuit for you real quick. I've removed everything besides the pin 3 and the resistor going to the LED from pin 3. So we have a resistor from pin 8 to 7. This is going to be a 10 meg. And then 7 is jumper to 6. And 6 goes to ground through a capacitor, so grab another wire here from 6. Let's go over here. This is a 10 microfarad. And then pin 2 is triggered with a switch. Pin 2 is actually connected to ground through the switch. So let's get some power. And there's actually another capacitor here. So we'll do pin 5. That guy. Alright, I ended up changing this 10 meg resistor to a 100 meg. Basically the voltage goes through this resistor to charge the capacitor. So if you have a bigger resistor and a bigger capacitor, it would take a lot longer to charge. Or if you have a smaller resistor, it would charge faster. But anyway, push the button. This is the monostable operation. It's like a little timer. So changing the value of this resistor R1 or this capacitor C1 changes the delay of your timer.